have a week and a half left and we are done. All done. Oops, wrong page, this one. So, we just have 2 days this week and 2 days next week, and that is it. I will finish up 9 today and start on 10, and then what I don't finish on today, I'll finish up on Wednesday. I will probably have time to do exam review on Wednesday as well as exam review on Monday. Your test is due today before hub closes. The hub closes at 8:30. You have to be in there by 7:30 or before. They will not let you in at 7:31. This will be your last test that you take in the hub. Your final exam you'll take with me. Okay? Remember, today's test is multiple choice, 20 questions. Your final exam is multiple choice, 33 questions. Okay? All right. Now, just to kind of get you back in the groove, because a lot of y'all were zoned out on me when we did 9.1. I'm going to go back and look at a problem just to kind of get you in the groove. I think that's all that review that I told you to go back over. What do I want to do? Yeah, let's 25. Okay. I'm just going to go over a little bit. Hello. Let's see if I got everybody. Rachel is here, Myers is here, Travis and Josh have not come in, Zalea is here, and DeQuasia has not come in. I was just telling them, 3 people have taken the test so far. I know, I looked up 2 grades, 2 were A's, the other one just came in, so I don't know what they made. The test is due today. It is 20 multiple choice questions. If I were you, I would review what we went over at the end of class on Monday and what we went over at the end of class on Wednesday. Don't review your homework, review the spreadsheet, and review what we went over at the end of class on Monday and at the end of class on Wednesday. Okay, this time at the end of week and a half, we are done. I'm going over a brief. A lot of y'all were kind of zoned out on Wednesday because you were thinking about the test or you were thinking about the weekend or whatever. 9.1, I'm going to kind of go over it briefly. Again, just one quick problem to get it back in our brain before we go over 9.2. This one was talking about a survey of 2,306 adult Americans aged 18 or older conducted, and we did this last time, I'm just going back over it. Found that 417 have a donated blood in the past 2 years. So to get our point estimate, that's our p-hat, that's our proportion. How many people donated blood? 417, and how many total people were in our sample? 2,306. So N is our sample size. X is how many people out of that sample did whatever we're asking for. So 417 people donated blood out of the 2,306 in the sample. So when I do that division, that's going to give me my p-hat, or my point estimate, or my sample proportion, however we want to call it. We good? And that's all they want in Part A, is obtain a point estimate. Give me the p-hat. Then, and like I said, we did this one last time, then it says verify that the requirements for constructing a confidence interval about P are satisfied. Now, on your test, there were 2 ways to verify. If we're talking about N had to be greater than or equal to 30. If we're talking about a P problem, we had to do the 2P things. And you had to memorize these on your test. N is less than or equal to 0.05 times big N. Little n is your sample size. Big N is your population size. Little n is your sample. Big N is your population. And then over here, little n times P 1 minus P, remember, is the naught, has to be greater than or equal to 10. So, we want to verify that. So our sample size was 23, I wrote, that should have been 06, not 07. Should have been 2306, not 07. So our sample size is 2306. Our population was adult Americans. And we know that there's a lot of adult Americans. So if we take adult Americans and multiply it by 0.05, we know that that number is going to be bigger than 2306. So that one's correct. Then we came over here. N is our 2306. 0.181 is our P. And then we do 1 minus 0.181. And when we go to our calculator and type that in, we got that that number is greater than or equal to 10. Now, because both of these are yes, what is that telling me? That my graph is going to look like what? Normal. Approximately normal. So they are satisfied. It's going to be approximately normal. And on your test, have we ever done any one of these that were not approximately normal? No. That's the pretty version. Now, it says construct a 90% confidence interval for the population proportions of adult Americans who have donated blood in the past 2 years. Now, when we were doing 9.1, we said that we were going to take our p-hat, which is our sample proportion, and we were going to do our margin of error off of that, and that was going to give us our confidence interval. And that said, if our sample says this, then we're going to be whatever percent confident that our population is going to stay between these two things. So, in order to do our confidence interval, we go to our calculator, and we did stat, we went over to test, and we went down to oh, no, I'm not doing that one. Stat, over to test. It was A, and we are saying that X, which is 417 people had donated blood out of 2306, we want a 90% confidence interval, so that's 0.9. And this was A. This was test A when we go to that whole list. So that said, if 0.191, 417 over 2306, and we're 90% confident, this is going to be our 90% confidence interval. That we are 90% confident that the population is going to fall between these two numbers. We good? Because what we're going to do, and that's where these two numbers are coming from, is right here. That's where those numbers are coming from when I hit enter. Interpret the interval as what I just said. We are 90% confident that the proportion of adult males, Americans, that is our proportion, who have donated in the last 2 years will be between 16.8 and 19.4%, or 0.168 and 0.194. That is what we did in 9.1. Now, we're going to do something very similar in 9.2. I just wanted to get you kind of got back in the groove. Just to remind you, for those that came in, this week we're going to be finishing up 9 and 10. I should have enough time to start reviewing on Wednesday. So we'll do exam review, hopefully some on Wednesday, and then finish up on Monday, and then have your final exam a week from Monday. A week from Wednesday. Now, so 9.1, we had p-hat in the middle. We had p-hat in the middle, and then we did a little margin of error to get our confidence interval. This one's going to be a little different. Instead of having p-hat in the middle, we're going to have this in the middle. This is going to be our unknown, our standard deviation. So this is 9.2. We're still doing confidence intervals. Confidence interval about a population mean where the standard deviation is unknown. A T interval should be constructed if the sample is random the population from which the sample is drawn is normal, but the population standard deviation is unknown. So for this one, we are doing a standard deviation. That's the only difference between the T and the Z is the standard deviation. We were doing the T, we're now doing, the Z, we're now doing the T. Standard deviation is going to be our only difference. Move up so you can copy. Degrees of freedom are going to be n-1, and we'll talk about that in just a minute. And we're going to use our table. Is this one going to give me everything I need? I need to give the whole formula sheet. I'm going to take these back up, but I'm just going to give you one to let you practice with. Oh, my bad. This is the same formula sheet that y'all been getting on your test. And that y'all been getting on your test and that you'll get for your final exam as well. Alright. Scroll it up a little bit more.
Can you scroll up just
I can do whatever you want me to
right
do.
there? Thank you.
Uh-huh. Let's see who I miss. James, we know is gone. Travis has not come in. Zelaya is here. Equation is here. These are not as bad as it looks. Scroll up just a little bit, give you a chance to copy. DF stands for degrees of freedom. A little bit more. Like I said, we're going to be finding the T interval this time instead of the Z interval. We're going to be using a table to find the degrees of freedom, the rho and the C level, which is our confidence level. The table calculates to the right. We're going to make the value negative if we're finding the area to the left. And I'm going to do several of these. It's a lot easier than it looks. And then in our calculator to do the T interval, we're going to hit the stats button. We're going to go over to test. And then we're going to choose number 8, which is the T interval. And right is where I'm gonna put in 9.1 versus 9.2. And 9.1, we did test A, which was the one proportion Z interval. In this one, we're doing number 8, which is the T interval. Now, well, in 9.1, all they asked us for was the X, the N, and the C. In this problem, they're going to ask us for the X bar, the SX, the N, and the C. So, when you're doing a homework problem and you're like, what kind of problem is this? Is this a Z interval or is this a T interval? All you have to ask is, what was I given in the problem? They both have an X, they both have an N, they both have a C. So if you're given the standard deviation, then you know it's going to be a T interval. That's why I wrote at the top that if it's got standard deviation, then you know that it's going to be a Z. So if it's got the standard deviation, you know it's going to be the T interval. They both have an X, they both have an N, they both have a C. But if it has the standard deviation, you know it's going to be a T interval. So we're going to do stat, we're going to go over to test, and instead of going down to A, we're going to go down to number 8, which is the T interval. We're going to enter the values, okay? Now, sometimes it's not going to give us all the values, so we may have to enter the values, which I'm going to show you in just a minute. Most of the time, we'll tell you what the X is, what the N is, what the SX is, what the C is. But if I don't tell you all those values, we're going to have to calculate those values. And finally, a couple of facts at the bottom. If we increase the sample size, the margin of error decreases, which means if we ask more people, instead of asking 5 people, we ask 500 people. The more people you ask, the smaller the margin of error, the smaller the confidence interval. You're not going to have much wiggle room. So the more people you ask, the narrower the margin's going to get. Increasing the C level, increasing the confidence interval also increases the margin of error. So as you increase the confidence level, you also increase the margin of error. So if I have a 90% confidence error, if I have a 90% confidence error, it may be from here to here. If I increase it to a 95, it's going to increase even more. So the higher the confidence, the wider the range, the wider the interval, the wider the confidence interval. Outliers will also create a wider confidence interval. If we have one person that made really low or one person that made really wide, a high, that's going to cause my confidence interval to be wide. And I've already said this before, if standard deviation is in there, that is what's telling us that we need the T. So if we're doing standard deviation, that tells us why we're using the T and not the Z. Alright, so let's try a couple of examples. Like I said, this is not as bad as it looks. Do I need to stay on this page for another few minutes?
Just a second.
Okay. And remember, you do not have a separate test on 9 and 10. You just have a couple of questions on the final exam for 9 and 10. All right, let me Find the t-value such that the area in the right tail is 0.10 with a 25-degree area of degrees of freedom. So, on your formula sheet, if you turn so that there's just one page left, it's going to be the front of that back page. Let's see if I can pull it up too. Let's see if I can get it to kind of show you. Where did it go? Formula sheet. We are doing, do you see that degrees of freedom are along the left-hand side and area to the right is on the top? Let me pull it up so I can walk you through it. Slip this into your notes so that we'll have it. So this is the table I'm looking at. Copy. Page. Paste. Snag this problem. Copy. And paste. So we want to find the t-value such that the area in the right tail is 0.10 with a degrees of freedom of 25. So our degrees of freedom are here. So we want to find a degrees of freedom of 25. So there's my 25 degrees of freedom. I can get my highlighter. Degrees of freedom are 25 right there. That's the column of the row that I'm looking for. Now it says we want a right tail of 0.10. So there's my 0.10, and where they cross is 1.316. Now at the top of the chart, go back and find it. At the top of the chart, it tells you so that you don't have to memorize, is it to the right or is this table to the left? It tells you at the top that this table is to the right. So you don't have to memorize that. It tells you that all these values are values to the right. So because I want the area to the right, then that's what this is. So your answer is going to be that 1.316. Now, if it was the area to the left, we just make it negative. Yay? So they're telling me right here that it is the area to the right, which is what I want. So that's going to be my answer, 1.316. So let's look at another one. Find the t-value such that the area in the right tail is 0.05 with a 30 degrees of freedom. Don't say it out loud yet. We want the area in the right tail is 0.05 with 30 degrees of freedom. All right, look up when you're ready. That's what it should be. Easy breezy? Okay. Find the t-value such that the area left of the t-value is 0.01 with 18 degrees of freedom. Area to the left of the t-value is 0.01 with 18 degrees of freedom. So we're gonna go 0.01 and we're gonna go 18. And that tells me the to the right. But because it's to the left, all we do is we make it negative. So because it's to the left, that's why it's negative. Did everybody get that one? 2.552 would be the answer if it was to the right. But because it's negative, it's going to be to the left. Cool? All right, let's get a little bit harder. Find the critical t value that corresponds to 90% confidence. Assume 20 degrees of freedom. Okay. Now, they gave you the degrees of freedom, but they didn't give you that number on the top. How are we going to get that number on the top? What does 90% confidence mean? Where's that 90% going to be shaded?
To the right.
Confidence is
In the middle.
in the middle. Okay? From this to this, confidence is in the middle. So this represents my 0.9. Okay? Now, if that's 0.9, what are these two going to be added up? 0.10. Because 90% plus 10% is 100%. So these are going to be 0.10. So how do I get just one of them?
Divided by 2
Divided by 2.
is 0.05.
So it's 0.05. So this is going to be 0.05 and this is going to be 0.05. So I did 1 minus 0.9 and that gave me 0.10, which is both tails. Then I divided it by 2 and that gave me that each tail is 0.05. Are we good? So 0.05 is going to be the number at the top of the chart. So they didn't tell it to me, but they knew, I knew enough from the 90% to figure out what the 5% were. So if I do 20 degrees of freedom and a 0.05, 20 degrees of freedom and a 0.05, what would that be?
1.725.
So that means, and it didn't tell me which one, so what would this one be?
Positive.
Positive 1.725, and this one would be negative 1.725. So that one was a little bit harder because you had to do the math to figure out the two tails. So if I'm 90% confident, so 90% is going to be here, that means 5% is going to be below and 5% is going to be above. And this is just the prettier version of it. All right, let me cover up. A simple random sample of size n is drawn from a population that has a normal distribution. The sample mean x bar is found to be 50. The sample standard deviation s is found to be 8. Construct a 98% confidence interval. Now, anytime I hear confidence interval, I'm thinking, is it the A test, which is 1 proportion z interval? Or is it that number 8, which was the t interval? And I told you that all you're going to do is you're going to look for what you were given. S, X, and C. So in this problem, we just need to figure out what we were given. What does 50 represent in this problem? Which of those letters does 50 represent?
This here. Next bar.
So x bar is going to be 50. What does 8 equal? 8 is going to be my standard deviation. And then they told me that n is 20, and then what is my c going to be? My C is gonna be 0.98. So because this problem has an SX, that is automatically telling me that I'm gonna do my T interval. Because it has an SX, because there's a standard deviation, it is screaming that I need to do my T interval. So because there's a standard deviation, that's why I need to do my T interval. So I'm gonna go to stat, over to test, and I'm gonna go down to number 8. You can get there. T interval.